It was faster than sound itself, sharper than any fighter of its generation. So powerful, it could compress the atmosphere around it until even the toughest metals bent and twisted under the force. But speed wasn't the most terrifying thing about this machine. The year was 1933. A young Swedish-American engineer, raised on a farm and fresh out of the University of Michigan, landed a modest job at Lockheed. Nobody imagined this quiet kid would become one of the most influential designers in military aviation history. His name was Clarence Kelly Johnson, and his first major project proved he wasn't just brilliant, he was fearless. Johnson openly criticized the design flaws in Lockheed's Electra, a move that could have gotten him fired on the spot. Instead, they sent him back to the wind tunnel at his university with a clear mission: fix what you broke. He did more than that. He completely redesigned the aircraft's tail section, introducing the iconic twin vertical stabilizer configuration that would become his signature. This was just the beginning. While the world prepared for unprecedented war, Johnson worked in shadows. During his time on the Hudson bomber, he secretly sketched what would become his masterpiece, the P-38 Lightning. This aircraft shattered every convention. Instead of a single fuselage with a front-mounted propeller, the P-38 featured a radical twin-boom design with the cockpit mounted centrally. This allowed superior weight distribution, space for turbochargers in the booms, and most critically, devastating firepower concentrated in the nose. No propeller blades interfered with the weapons. For 50 caliber machine guns and one 20mm cannon fired in perfect alignment with surgical precision. A single trigger pull could disintegrate an enemy fighter midair. But the real breakthrough wasn't the guns, it was the aerodynamics. Johnson demanded absolute precision. Flush rivets, perfectly aligned panels with no overlaps, metal skin with curvature varying by thousandths of an inch to achieve completely smooth surfaces. Every detail was calculated to minimize air resistance. Even the ailerons and control surfaces, typically fabric on other aircraft, were constructed from aluminum, providing faster and more reliable responses at high speeds. This obsession with speed led the P-38 to encounter one of aviation's deadliest enemies: compressibility. Compressibility occurs when an aircraft approaches the speed of sound. Airflow over the wings becomes supersonic, generating shock waves that completely alter the aircraft's behavior. Control vanishes. The plane stops flying and becomes a falling projectile. Many pilots died without understanding what happened. They simply lost control. The aircraft became a death trap. This is exactly what happened to Captain Robin Olds, one of World War II's legendary aces. During a steep dive to save a wingman under attack by two enemy fighters, his P-38 exceeded 500 miles per hour. The cockpit began shaking violently. The control stick became useless. The aircraft, now an unguided missile, plummeted toward German soil. Nobody had survived this before, but Robin Olds did. The reason was dive flaps installed beneath the wings that altered airflow over them. They didn't just slow the aircraft, they changed its lift characteristics. Thanks to that innovation, he regained control mere feet from the ground. This system was designed by a young engineer working under Johnson's direction, and his invention saved dozens, if not hundreds, of pilot lives. But the P-38's limitation was clear. Its propeller, although Allison engines increased power throughout the war, the aircraft's top speed only grew by about 20 miles per hour. The propeller's drag prevented breaking the sound barrier. Johnson understood this perfectly and wrote it clearly: if we want more performance, we must eliminate the propeller. That thought planted the seeds for America's first serious jet, the P-80 Shooting Star. But that was still years away. Meanwhile, the P-38 ruled the skies and remained one of the best-kept secrets. The aircraft's development happened with unprecedented secrecy, leading Johnson to create a work method that would define the future of military engineering. Skunkworks, a small, elite team without bureaucracy, without interference, just the best minds working under 14 rules that prioritized efficiency over corporate politics. Among them, one stood out: have a single technical leader with total authority. Another was equally blunt: use the smallest number of people possible. This approach allowed Johnson and his team to create marvels in record time, and it all started with the P-38. When it entered service, it changed aerial warfare. Its two engines produced over 2,000 combined horsepower. Its speed exceeded 400 miles per hour, Its service ceiling was over 40,000 feet, and its range of more than 900 miles made it the perfect escort for bombers on deep missions. The Germans called it the fork-tailed devil. The Japanese simply said 2 planes, 1 pilot. It was so strange and lethal it seemed pulled from science fiction. But this was just the beginning. Though the P-38 Lightning dominated skies on many fronts, its story is also marked by losses, accidents, and even sabotage. In its early missions over Europe, the aircraft proved lethal but also fragile. Extreme cold in northern European skies caused engine failures. Many pilots crashed due to frozen fuel injection systems. Johnson knew this. The P-38 was designed for the Pacific War, not the winters of Norway or Germany. However, there was no time for complete redesign, so Lockheed implemented improvised solutions: thermal insulation, cowling heaters, and more frequent mechanical inspections. Still, losses continued. Many pilots died without ever entering combat. But in the Pacific, the P-38 truly shined as a predator. Its great range allowed it to escort B-24 or B-17 bombers for hours and still fight. And its firepower was simply overwhelming against Japanese fighters, which were more agile but far more vulnerable. In fact, it was a P-38 responsible for one of the war's most daring operations, Operation Vengeance. In April 1943, intelligence services decoded that Japanese Admiral Isoroku Yamamoto, mastermind behind the Pearl Harbor attack, would conduct an inspection tour in the Solomon Islands. Immediately, an operation was designed to intercept him mid-flight. 18 P-38s took off on an extremely dangerous mission. They had to fly over 600 miles at wave-top level, evading radars without being detected. When enemy aircraft appeared, American fighters rose like lightning. In less than 5 minutes, Yamamoto was dead. His aircraft was shot down with surgical precision. It was a devastating blow to Japanese morale and a symbol of the P-38's lethal reach. And while this unfolded in the Pacific, Clarence Johnson's mind was already elsewhere. He was thinking beyond the propeller, beyond World War II. He wanted to create an aircraft that would make all current fighters obsolete. Thus began his obsession with supersonic speed. During the 1950s, Johnson led development of a completely revolutionary aircraft, the A-12, which would later become the SR-71 Blackbird. But before reaching that beast, the intermediate step would be an aircraft capable of flying at Mach 2, twice the speed of sound. And here enters the true protagonist of this story, the F-104. This aircraft was built with a single idea in mind: go faster than everyone else. It was narrow, slender, with wings so small they barely seemed functional. It had a fuselage shaped like an elongated bullet, designed to pierce through air with minimal resistance. And its engine, the J-79, offered unmatched raw power for its era. In level flight, it could reach speeds up to 1,500 miles per hour. It was so fast that shock waves generated by its nose could alter airflow around it. Under certain conditions, air compressed so intensely around the fuselage that it caused certain aluminum panels to deform. Literally, the aircraft warped metal around it while flying, but this monstrous speed came at a price. The F-104 was famous for its nickname, the Widowmaker. Its accident rate was extremely high. In some European squadrons, more than half the units ended up crashed. The reason was simple. The aircraft was so advanced, so sharp, so fast, that any mistake was paid with life. It didn't forgive errors. Its tiny wings, for example, gave it great speed and maneuverability at high altitude, but also meant it needed to land at extremely high speeds. Many pilots couldn't brake in time. Others fell victim to the primitive ejection system, which in early versions fired the pilot downward fatal if the maneuver was performed at low altitude. Still, it was one of NATO's most widely used aircraft during the 1960s and 70s, and despite its flaws, its design directly influenced later aircraft like the F-15 and F-16. But Clarence Johnson didn't stop there. His greatest masterpiece was still to come on: aircraft that wouldn't just fly faster than any other, but would do so at impossible altitudes. An aircraft black as night, invisible to radar, and capable of spying from the edge of space. But to achieve that, he first had to solve a bigger problem: atmospheric friction. At speeds near Mach 3, air doesn't just compress, it heats up. And when that happens, traditional materials can't withstand it. Aluminum melts, steel deforms. It was necessary to build an entire aircraft from titanium, an extremely expensive metal that was difficult to work with and scarce in the United States. The solution: Johnson convinced the US government to purchase titanium through shell companies from the very enemy itself. Most of the titanium used to build the SR-71 was bought from the Soviet Union. The result was a legendary machine. The Blackbird could fly at over 85,000 feet at speeds exceeding 2,200 miles per hour, and as it did, the aircraft literally expanded. Joints, panels, and bolts were designed to dilate with extreme heat. On the ground, the aircraft leaked fuel everywhere. But in flight, everything fit together like Swiss clockwork. It was so fast that no missile could catch it, and so advanced that even today, more than 50 years later, it remains unmatched in many aspects. For decades, the Blackbird flew over Soviet, Chinese, North Korean, Vietnamese, Middle Eastern, and many other sensitive skies. Not a single missile ever hit it. Not one was shot down. Because when a missile launched in its direction, the pilot simply accelerated. At that altitude and speed, reaction time was so brief that no defense system could keep pace. One of the Senior 71's most fascinating details is that it never flew slow. On the ground, yes, it leaked fuel from all its joints, but in flight, the aircraft was perfect. Its panels expanded, its structure adjusted to heat, and the result was a craft that seemed pulled from science fiction. Yet the Blackbird program was canceled. Why? The answer is complex. On one hand, costs were astronomical. On the other, spy satellites began offering similar surveillance capabilities without risking pilots. Additionally, the arrival of stealth aircraft like the F-117 Nighthawk and later the B-2 Spirit changed the rules of the game. But one thing must remain clear: no aircraft, before or since, has matched the SR-71 Blackbird in its ability to combine speed, altitude, and espionage technology. And it all started with a war, with a young engineer who refused to accept limits, with a dream of going higher, farther, faster, if it meant warping metal, defying physics, or convincing the Pentagon to invest millions in impossible ideas. The P-38 Lightning proved that a fighter could have two tails. The F-104 Starfighter proved that speed had a price. And the SR-71 Blackbird proved that the wildest dreams can sometimes fly. The story of these aircraft isn't just a story of combatants, a story of vision, risk, and ingenuity. And if one name must be remembered, it's Clarence Kelly Johnson, the genius who made it all possible.